Hello everyone, my name is Bruce, and today we're going to be doing another statics problem. And this one it's from chapter 2, which is force systems, and this is a three-dimensional problem, as you can see. The problem asks, express f as a vector in terms of unit vectors I, j, and k. Determine projection both as scalar and as a vector of f onto line OA, which lies in the xy plane. So, we need to find f as a vector, so we'll start off by doing that first. And they give us these values here, the angles. So we'll just say f equal to f times the n, which is the unit vector. So this is essentially f is equal to f dot n. There we go. So, sorry about that. It's the finicky touchscreen laptop. Okay, so we start out with x, so it's going to be in the negative direction, so it's going to be negative, what's that, sine 35? Oh, tricky. Actually, if you notice here, that would be if we had the force going across the bottom here. So we'll first have to find this f, which we'll call fxy, and that's going to be equal to the cosine of 50, because we know that this angle here is 50. So cosine 50, it's going to be times f, and fz is going to be f sine 50. And then we split the fxy into x and y components again. So that's just going to be from this line here. So the x component is going to be, I'll write it in red here. X is going to be like this, and the y, being blue, is going to be like this. So, keeping up with the whole red theme, fx is equal to this cosine 50 times sine 35. And in blue we have fy, and that's going to be equal to f cosine 50 cosine 35. And these are actually both going to be negative, but we won't worry about that right now. I'm getting a phone call. Sorry about that. Okay, sorry about that. So we have f of x, which would be negative cosine 50 sine 35. We're running into this, and that's an I. And let's see, j would also be negative, so negative cosine 50 cosine 35. This is running on a little bit. And then that's going to be positive, so plus sine 50. Ah! Not cool. Okay, there we go. That sort of ran on a little bit, but it shouldn't be too difficult to solve, seeing as f is 5 kilonewtons. So, just plugging in the numbers, I'll just do that quickly. And whoops, a little mistake there is actually the y's are going to be positive. Just remember that. So yeah, this is what we get for the f in terms of the unit vectors. So now we have to find the projection both as a scalar and a vector of f onto line OA. So we simply go projection is equal to f dot NOA. Okay, there we go. So, and that will give us a magnitude, which would be the scalar. So we'll have negative 1.84 I plus 2.63 j plus 3.83k, and that is the f unit vector, and that's going to be dot. Now for this, all we have to do is we just say that a is going to be in the xy, which means there's 0k. So we have for the x is going to be cosine 30, and then for the y is going to be sine 30. Again, sorry about that. Let's see here. And I'll just quickly multiply that out. And that is what we get there. Yeah, so that's what we have right now. And this is just the magnitude, as I said before, the scalar. So to convert it into a vector, we simply just say f, OA, or projection, or whatever. And that is going to be this dot the unit vector, which is just going to be the same exact thing. So we're just going to have -0.278 dot cosine 30 I plus sine 30j, and that will give us, and it'll give us that. Just multiplying it out, and that's basically how we solve it. So the key things to remember are as f in unit vector terms, f in a vector, I, j, and k, you just multiply by a unit vector. Unit vector is just the distances or the angles, whatever you want to think of it. And then for projection, you just start multiplying it by the unit vector of the line that you want to project it onto. And that's pretty much it. So that's your answer, and you can check it, and check out some of my other videos.